See here, a divide and conquer algorithm is mainly used to solve complex or large problem. So what is recursion? Calling same method again and again until the given condition is true, that is known as recursion. What is the size of the array? That is nothing but the 7. And what is my key? Key is nothing but the 4. Okay, and I'm going to call the binary search. Hello to all, a warm welcome to my new topic, that is divide and conquer. I'm Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my today's session, I'm going to deal with what is divide and conquer technique. Along with that, I'm going to deal with the binary search and merge sort. Anyway, let's start with our today's session, that is divide and conquer technique. So what is divide and conquer? As the name itself indicates that divide the given problem or task into number of subtasks and conquer the module in order to get the final solution. So divide and conquer is an most commonly used algorithm used to breaking down the complex problem into smaller problem. Find the solution for this smaller problem and combine the solution at the end in order to get the final solution. So it is a divide and conquer algorithm in which the problems are divided, conquer and combine strategy. In the sense what? Think that I have the complex problem. So what I will do? I will divide this complex problem into smaller sub-problem. Okay, it is breaking down. Okay, fine. And find the solution for individual problem and combine the solution. This is nothing but the divide and conquer. So using divide and conquer technique, which divide the problem into sub-problem. So here, which is the sub-problem, this is nothing but the sub-problem or sub-module. So here, it uses 3 strategy: divide, conquer and combine. So divide in the sense what? Dividing the problem into smaller slice. Then find the solution for individual slice. Okay, so conquer, solve the sub problem by using calling recursive method. Recursive method in the sense what? Calling the same method again and again. In one function, if I call same function again, then it is called recursive. So calling the same function again and again until the given condition is true. So conquer, solve the sub problem by calling recursive function. Then combine the sub problem to get the final solution. So it is divide, conquer and combine. Okay, fine. See here, a divide and conquer algorithm is mainly used to solve complex or large problem. And what I will do, I'm going to break the problem into smaller sub-problem or module. So what I will do, I'll solve the sub-problem. So first what I'll do, I'll divide the problem. Okay, then I'm going to get the sub-problem. So what I'm going to do here, I'm going to solve the problem. Okay, I'm going to solve the sub-problem. At the end, I'm going to combine the problem to get the final solution. So it is divide, conquer and combine. So dividing the given problem into sub-problems using recursion. So in divide and conquer technique, we use the concept called recursion. So what is recursion? Calling the same method again and again until the given condition is true. Then solve the smaller problem recursively. So what I will do, I'll solve the sub-problem, okay, smaller sub-problem recursively. If the sub-problem is small enough, then we directly solve it. So I can able to use recursive function or normal function. And at the end, what I will do, I'm going to combine the solution in order to get the final solution. Now let me to explain this concept with the help of diagram. So this is my complex problem. What? Complex problem. Complex problem. Okay, fine. What I will do, I'll divide this one into two sub-problems. So sub-problem 1 and sub-problem 2. Okay, fine. Then I'm going to find the solution for individual sub-problem. Okay, so it is nothing but the sub-solution. So where? In my conquer stage. Okay, fine. Then once the solution is ready, what I will do? I'll combine the solution in order to get the final solution. Okay, see here. In divide and conquer technique, okay, we can have the binary search, we can have the merge sort, and even I can have the quick sort. Okay, so here what I will do, I'll divide the complex problem into smaller sub-problem, and I'm going to find the solution for individual sub-problem, and I'm going to combine the solution. So these are the some of the example for divide and conquer algorithm. Most commonly we use binary search and merge sort and quick sort. So dear student, in my today's session, I'm going to deal with binary search. So what is binary search? Okay, before going to explain binary search, let me to consider searching. Searching in the sense what? Finding something. Okay, fine. So here what I will do, I'm going to take a list of sorted array. What I will take? I'm going to take the list of sorted array. For example, my array value is n. Okay, n is nothing but 5. Okay, fine. Then what I will do? I'll read 5 elements. So 1, 2, 3, 4 and 5. And the index starts from 0, 1, 2, it is 3 and it is 4. Okay, fine. Now, what I will do, I'm going to divide the problem. How I'm going to divide? Based on the mid value. So, it is my low and it is my high. Okay. So, it is low 0 plus 4. It is 4 divided by 2. So, what's my midpoint? It is 2. So, this is my midpoint. Okay, fine. Now, see here. If I consider 3, here also I'm going to have the sorted array. Here also I'm going to have the sorted array. Once again, what I will do? I'm going to apply same procedure in order to find the element. So, in binary search, I'm going to consider the key value. Okay, initially what I will do? I'll compare with the mid value. For example, if key is 3, so key is present at the location 2 because my mid is 3, 3 equal to 3. Okay, so it is true. So the element is present at the location 2. Okay, fine. Binary search is a searching algorithm for finding the elements position in a sorted array. So what I want to do here? What's my basic requirement? That is, I must have the sorted array. Okay, fine. So this element is always searched in the middle of the portion of an array. I'm going to break the array into 2 parts. Over. So what is divide and conquer? Divide the problem and find the solution. So here also I'm going to break the array into 2 parts initially. See here, binary search algorithm can be implemented in 2 ways. One is by using iterative method, okay, without any recursion, and another one is recursion. So what is recursion? Calling same method again and again until the given condition is true, that is known as recursion. So here we follow the divide, that is we follow the recursive method, okay, to implement binary search. Initially, what I will do, I'm going to have the key value. At the same time, I'm going to have the array element. And if I see the array element, okay, all the elements are sorted. How many elements? 1, 2, 3, 4, 5, 6 and 7. So, index starts from 0, 1, 2, 3, 4, 5 and 6. Dear student, 0 is nothing but the low and high. That's nothing but the 6 is nothing but the high. Okay, fine. See here, I have low and I have high. This is my second step. In my third step, what I will do, I'll add low and high. That is low plus high. 0 plus 6 divided by 2. 0 plus 6, it is divided by 2 in the sense what? What I'm getting? I'm getting, okay, that is 6 by 2. It's nothing but the 3. So position 0, 1, 2, 3, 4, 5 and 6. So array of low plus high in the sense what? Element which is present at the position 3. I have the value 6. I have the value 6. So this is my mid now. Okay, fine. Now what about key? Key is present at the left side. Okay, so I just want to consider this array. See, 4 which is present at the left side of the given array. Next, okay, in my second, that is in my fourth step, what I will do, I'll check if x is what? Key equal to mid. Mid is how much? 6. Then I'm going to return the mid. Suppose if the condition is false, else compare the element to be searched within, okay, M. If x, so what is x? X is 4 greater than, okay, mid, then I'm going to compare with the middle element. So what I want to do, see here, 0, that is low as it is. Then what about high? How I'm going to find? That is nothing but the middle minus 1. So what is middle? Middle is 3. 3 minus 1, that is nothing but the 2. Okay, I'm going to point 2. Okay, fine. Now what is my low? Low is 0. And what about middle? That is nothing but the, what about high? That is nothing but the middle minus 1. Middle is how much? 3. 3 minus 1, 2. Okay, fine. See here. 3 minus 1, it is 2. 0 plus 2. So it is 2 by 2. That is nothing but the 1. So if I consider the index 0, 1 and 2, which is my middle now. Middle is nothing but the 4. Now what I will do? I'll check. Okay, mid equal to x. I'm going to check mid equal to x. So what is mid? Mid is 4. 4 is equal to 4. The condition is true. And I'm going to display the key value x is present at the position 1. So it is key is found. Okay, fine. Anyway, dear student, let's discuss the algorithm, that is binary search algorithm. So binary search algorithm, it's taking 4 element, that is array, key, low value and high value. Initially, low is going to point the 0th index. So 0 greater than high. If it returns false, okay, else mid equal to mid. How to find mid? That is low plus high divided by 2. Then what I will do? I'll compare key equal to array of mid. If it is true, what I will do? I'm going to return the mid value. Else, if key greater than array of mid, then what I will do? I'm going to call the binary search. So it is example for recursion. So what is the recursive algorithm? Calling the same method again and again inside the method. So what's my method name? Binary search. And what I'm doing here, I'm going to call the method inside the binary search. Here also I'm going to call the method inside the binary search. And this is known as recursive or recursion. Okay, fine. So this is the code. int binary search. Okay, I'm going to have the array element. I'm going to have the key, low value and high. Initially what I will do, I'll check while low less than or equal to high, index always low, that is 0, less than or equal to high, it is true. Then what I will do, I'm going to find the mid value. Next what I will do, I'm going to compare with the mid, that is mid equal to key. If key is found, x is nothing but the key. If key is found, what I will do, I'm going to return the mid. Else, okay, suppose array of mid is less than key, then what I want to do, I want to point low equal to mid plus 1. Else what I want to do, high equal to mid minus 1. This is the way, okay, I'm going to write the binary search program. Now I'm going to have the main function and I'm passing the value 3, 4, 5, 6, 7, 8 and 9. How many? 7 element. Okay, to get the size of the n, I'm going to call size of operator. Okay, so what is the size of the array? That is nothing but the 7. And what is my key? Key is nothing but the 4. Okay, and I'm going to call the binary search. Okay, and passing the array, I'm passing the key 4. Low is nothing but the 0 and high is nothing but n minus 1. If the result equal to minus 1, because see here, I'm returning the value. So if I return minus 1, then what's the meaning? Key is not found in the given array. Else, key is found at the index and I just want to display the index value. Okay, at the position, in which position I got the key. Okay, fine. Then I'm going to have one more searching algorithm, that is nothing but the merge sort algorithm. Over. So what I will do, I'm going to divide the complex task into smaller tasks. Okay. After that, I'm going to find the solution. Then at the end, I'm going to club the solution. Merge sort is one of the most popular sorting algorithm that is based on the principle of divide and conquer algorithm. How the problems are divided? Okay, so we are going to divide the problems into number of multiple sub problems and we are finding the solution for each sub problem, and at the end we are going to combine the solution in order to get the final solution. Let me to consider the simple example here. Okay, 6, 5, 12, 10, 9 and 1. How many elements? There are 6 elements. I'm going to make it 2 sub-task or sub-module, that is 6, 5, 12 and 10, 9, 1. So this is my sub-problem. Okay, fine. Further what I will do, I'll divide this sub-problem into one more sub-problem, that is 6 and 12. Here it is 10 and 9, 1. Okay, fine. Now, once again, I'm going to split, that is 5 and 12. Okay, so single digit. Here also 10, 9 and 1. Now, what I will do, okay, see, I just swapping each other, that is 5 and 12. Here it is 1 and 9. And now I'm going to combine the solution, that is I have 6, 5, 12. Now, what I'm going to do, I'm going to swap, in the sense what I'm going to sort 5, 6, 12. Here it is, okay, 9, that is 10, 1, 9. After sorting 1, 9, 10. So here the final result is 1, 5, 6, 9, 10 and 12. This is my sorted array. So this is the way merge sort is going to work. Okay, fine. Now let me to consider the merge sort algorithm. So I'm going to have merge sort. A is nothing but the array name and lower index and higher index. So initially, to divide the complex problem into sub problem, what I will do, P plus R divided by 2. Then I'm going to call the recursive function. And if I see this code, it is nothing but your binary search code. Okay. So I'm just calling the recursive function. And at the end, what I will do, I'm going to club the final solution. That's nothing but the merge. Okay, so this is nothing but the combining the solution. Okay, fine. Now, if I consider the time complexity of an merge sort, okay, in the best case, I'm going to get big O. That's nothing but the best case. Okay, if I consider the worst case, that is, what is a worst case? That is big O of n into log n. See, in all the situation, I'm going to get n log n. So what's the time complexity? If I consider best case, worst case, or average case, I'm getting n log n. And what about the space complexity? That is nothing but the big O of n. So this is nothing but the time complexity. Okay, fine. This is the way I can able to sort the element by using merge sort. So dear student, this is the way I can able to sort the given array element by using merge sort. Anyway, dear student, let's meet in the next session with some more interesting topic. Until that, keep learning and keep watching. Thank you.